Welcome to Brain Vision.
Okay, this is question 584. It's an interesting question. It says, if the coefficient of static friction between a table and a uniform massive rope is mu s, then what fraction of the rope can hang over the edge of the table without the rope sliding? So I'm going to call the fraction of the rope hanging over the edge of the table as f. So if half of the rope were hanging over the table, then this would be 1/2, for example. So this is what we're going to try to solve for. So the way we're going to do this is we need to consider the friction force on the part of the rope that's on the table. So the mass of the rope that's on the table is going to be 1 minus F times the mass. So I'll just say mass on table is this. And then the mass hanging off the table will be F times M. So again, if this were, half were hanging off, then this would be half the mass would be hanging off, and then 1 minus 1/2 would also be a half, so half would be sitting on the table. So this is how we're going to set up our equations here. So what we're going to need to do is, since we don't want the rope to be sliding at all, we want to set the friction force that's acting on the mass that's on the table to be equal to the gravitational force, which is the mass hanging off the table. So let's first consider the frictional force here. We're going to have the friction force is going to be equal to this coefficient of static friction times the normal force of the part of the mass sitting on the table. So the normal force is just going to be equal to the mass, which is 1 minus F times M times G. So this is the weight of the part of the rope that's on the table. And so this is the entire friction force acting on this rope. Now we want to set that equal to the weight, the gravitational force of the part of the rope that's hanging off the table. So the mass, again, is going to be this fraction, this F times M, and then we just need to multiply it by G to get the total weight. So now we want to be solving for F. So let's just rearrange this equation to solve for F. So the first thing we can do, we see that there's a factor of M and G in both of these terms. So we can just cancel this out. And now let's expand out this side on the left. So we're going to end up with mu s minus mu s times F equals F. Let's add this mu s times F term over here. This is going to let us now factor out that F. So pulling out a factor of F on both sides from both of these terms. And when we finally divide, we should get that this fraction is equal to mu s divided by 1 plus mu s. So this is the fraction of the rope that will be hanging off of the table, assuming that the rope is not sliding.